Okay, so thanks for coming along, everyone. My name is David Burela. I'm a senior technical evangelist at Microsoft. I'm based down in Melbourne. Now, with Microsoft, I've been going around, flying around Asia Pacific, doing a lot of initial blockchain proof of concepts with our customers. So these big enterprise customers around the APAC region. And I've been seeing a lot of things again and again, questions that arise when I go to talk about blockchain. Usually, what is it? How does it work? How does mining work? What is hashing, etc. And so my session today is I've got like 2 or 3 days worth of pure content I could just present non-stop for 3 days on this stuff. I condensed it down to about 2 hours of content that I'm going to present in 60 minutes. So I've got 120 slides. I'm just going to keep clicking rapidly. So my objectives for my talk today is, because there's just so much and all of you here are hearing about blockchain for the first time, my objectives for today is to just introduce what the blockchain is, try and explain a lot of different use cases for why you would want to use it, and just mainly get you guys excited about what it is and why you would want to use it. It's not just another database. And so my agenda for today, I'm going to cover off what is a blockchain, go and explain blockchain 1.0 technology, go and say why you should skip that and go straight to the 2.0 technology stuff. What is up on Azure, events you can go to in Australia to go and start learning about this stuff. That's the first 30 minutes. And then I'll go and spend the last half hour just on pure use cases, how cool and futuristic and just fucking cyberpunk this stuff is. So I just came back from holiday on 2 weeks, and I spent the 2 weeks on the coast of Croatia just sitting there with my Kindle, rereading back through Neuromancer, the original cyberpunk book, and going, oh, yeah, we can do this stuff now. It's cool. So all of my slides I got from, he used to be a Silverlight MVP, Alex Knight. So he now lives over in Japan, and he's been taking all these neon future, cyberpunk, futuristic photos around Japan. So I've just asked his permission to use his photos throughout here. So let's jump back before blockchain though. So when we wanted to go and buy something, we'd have to go and do it physically in person. Well, if I wanted to go and buy a phone, I'd have to we'll go meet somewhere, and I'll go to a physical store, I'll give them money, they'll give me the phone, yay. But the problem with that is having to be physically located to go and purchase things really limits what you can do. You have to travel to the next city, the next village, go to the store, etc. So when we got to online trading, e-commerce, this unlocked a whole bunch of stuff. I could go send them the money, they would go send me the phone, and we're all happy. Except for the scenarios that we've all heard on eBay, we send the money, they don't send the phone. What do we do then? So that's why we have this concept of trusted third parties. There's intermediaries that sit in the middle because we can't trust random anonymous people on the internet. We can't just send the money straight to the bank account. We go through PayPal, we go through eBay, and for the privilege of using them, they take the big cuts. And so what I want to do, and this is where all the crypto punk cyber futuristic stuff comes into, is let's just get rid of the corporations. We don't need them. What if instead of having to pay a trusted third party to do that for us, we use a smart contract on the blockchain? We spin up a smart contract for this transaction. I send the money into it. They go and send me the coin, send me the phone. Once I've got it, I go and send a message to the smart contract saying everything's good on my side. They send it saying everything's good on their side, and we go, and I forgot to start my timer. Start. We both sign it, and then the smart contract will unlock the funds and send it to the person. So that's all good, and if we do that, we've cut out those corporations, cut out the middleman, we're saving money on those merchant fees, we've got faster money transfers because it happens instantly. Now, there's a great joke that happens there. It's faster to send an anvil to China than it is to send money to China, because the amount of intermediaries and banks and clearinghouses it has to get through can take 7, 8 days to get the money there, or 2 days to send an anvil to China. Now, of course, things can still mess up. They may not send the phone, we may still have an argument. So what we can agree to up front when we create the smart contract is if there's any conflict or disagreements in the smart contract, it could go and bring in an intermediary to go and arbitrate between us. And there can be a penalty clause in the smart contract to go and trigger that. So we can still go and put some trust in it. Now, Let's move on to a business scenario. Now, we've all built systems exactly like this. We've got our company, we're interacting with another company, and we need to send purchase orders to each other. Now, we go and send it, but we've all seen this happen. As much as we put in as much checks and exception handling and etc., things just don't reconcile between the two companies. No matter how hard we try with service buses and all of this type of stuff. Things still get out of sync. We still have this monthly reconciliation process and they never line up. And so the next logical thing we usually go to is, okay, let's go and put a centralized database between it all. We can do that. And yeah, technically you can do that. Technology is not the problem here. The problem is governance. Once you've got this, the problem is who owns and controls the centralized database. It requires trust between all the parties around who's hosting it. It may be okay with just 2 parties, but if you've got 5 different companies all interacting with each other, who's going to be the company who's hosting that? You're putting a lot of trust in them to not go and mess with the data. And what if that company starts doing bad things? Then the other 4 don't have any recourse. So what if instead we put a blockchain in the middle? We can have now say the source of truth is the blockchain. So we're removing the trust and the governance from people and putting that trust into a blockchain instead. And how does it all work? Not through that, because that's just the advantage of the blockchain. The advantage of the blockchain is mostly, I'm going to keep driving this home, and eliminating the need for trusted middlemen, cutting out those corporations. We're reducing the fraud because we can trust the data that's in the blockchain. We can go and speed up things. We can go and confirm things instantly instead of waiting days or weeks for things to go through clearinghouses. We can reduce costs, etc. But the 4 main key tenets that all blockchain technologies have is that it's all based on cryptographic functions. I'll get into them more. It's distributed. We don't have one single database that's running this. This blockchain is replicated and decentralized over many, many, many nodes. So you can't just hack one node. You'd have to hack all nodes simultaneously, which is a lot harder. It's shared. The networking effect you get out of it, I'll talk about later, about calling into multiple smart contracts. And importantly, it's a ledger. So what is a ledger? It just looks like a normal accounting thing. It's just a line by line. David sent Bitcoins to Darren. Darren sent them to Matthew. Just line by line by line. So just a giant transaction log. And that's all Bitcoin really is under the covers. It's just a giant transaction log. I've got 5 Bitcoin. I'm sending them to someone. I'm sending them to someone else. So that's okay. We can have those. But how do we really know that the transaction that says David sent 5 Bitcoins to Darren, how do we know that that's a real transaction? And this is where all that cryptography comes in. It comes down to basic public-private key cryptography. I generate a public-private key pair, and my public key, that's what my Bitcoin address is. So we can go and assign 5 Bitcoin against just an address which says 1234, and we know that that address has 5 Bitcoin. So if I want to go and so I can see my account has 50 Ethereum, I want to send it off to Darren's address, I would just go write that transaction, send 5 from me to him, I'll sign it with my private key, so now everyone else on the network knows that this transaction is valid because it's going from this public key address and it's been signed with that private key, and everything gets updated through that transaction log. That's basics of blockchain. Now, some of the other things that are built on top of this though is cryptographic hashing functions. So in programming, we've all probably used SHA, MD5, etc. The idea that you can take a text string or a digital file like an image or a PDF, etc. You run it through an MD5 or SHA algorithm and you get out just a cryptographic value. The idea here being that if you change a single bit or a single character, so if you change a 5 to a 6, it massively changes the resulting output. So that way you can go and prevent fraud by seeing what if the cryptographic hash has changed. So if someone tries to modify that transaction, massively changes the hash. They can't go and change something under the covers. Another concept is this idea of Merkle trees, where instead of just having a single hash for a single value, we can go and combine all these hashes together up into a top-level hash. So we've got 4 individual bits of data. We can hash each of these individually. We can go and combine these 2 hashes into another hash. We can go and combine these ones into that. So we can go and use a single hash value to secure vast amount of data underneath it. And those are all the primitives you need to know about blockchain. From then on, it's rather simple. So inside of a blockchain, we have multiple blocks. A single block has a number of things. It has the address, it has the hash value, what the block before it was. It's got all of the transactions that are in this block, a nonce, and a hash for this block. I'll explain this in a second. So if we were to generate a new block, the first thing a block needs is what the hash was of the previous one, rather the block that we're building on top of. We go, put the transactions in that we want. We just start off with a nonce of 1, and then we go and hash this entire block. And what we see is that the hash of this block is 2F488, etc. Now, one of the rules with securing a blockchain is that this hash, it's got to be below a certain number. So this is why this block starts off with 00000, because it has to be below 9 quadrillion. And so the number's much larger. So this is where the idea of this Bitcoin mining comes in. To go, all these miners are trying to be the first one to find a valid block. So they keep on modifying the nonce. So they change it to 2, rehash it, it's still too big. It will go through trying random nonces, and this is why they're burning more electricity than some small countries around the world, running these algorithms, trying to be the first ones to find a valid nonce that will give, here you go, they finally found a valid nonce, give us the hash, which is below a certain number. Boom, they're the first person in the world to find it. They get rewarded with a couple of Bitcoin, which so every 10 minutes someone gets awarded something like $50,000 or something every 10 minutes. And then the winner gets the reward, and we keep going. So once someone has found a valid block, they will go announce it to the whole network. It will go get sent out, redistributed, and everything happens again. So everyone will start racing to be the first one to find the next block. Now, the reason why we secure it like this, that it makes it so hard for someone to find a valid block, is where all the security in blockchain comes from. So we keep on building these up. Each of these point to the hash of the block before it, which means when Darren sent me 5 Bitcoin, and I try to modify it, say, no, Darren sent me 500 Bitcoin, which is like a couple $1 million. If I go and change this transaction, what happens if I go and rehash this? Well, it means that this hash has changed because I changed like one small value here through that Merkle tree. This hash is massively changed, which means this block is now invalid because it's pointing to this hash address. So if I'm modifying this, I'd have to update this, which means this hash address is gone. And it just keeps going all the way up and up and up and up. So the point of this is to try and stop Troy Hunt's favorite people, the hackers wearing hoodies. In this case, we've got a Cyberpunk neon hacker going on here. But this is all the security that happens through blockchain is from this, trying to change something tiny in a block has massive repercussions, and I have to regenerate the entire blockchain, which I couldn't do on hardware available to me. Meanwhile, everyone else is still on the main real blockchain, still going forward, so I'll never catch up in time. And all of this, combining all of this together, meaning that we can trust the data that is inside of the blockchain, means that we get the internet of trust. So whereas the web and the internet is just the web of data, we can't trust in the information or data that's on there because it can be changed at any point in time. The blockchain is the internet of trust. And this is where all of the things are built on top of. Now, we've got 3 main things to consider when we're looking at blockchain technology. If you're thinking about using this in your application, the first one is, where is your application's target audience? Is it a consumer-to-consumer app or a business-to-consumer app? If so, it's probably going to be a public blockchain, which is at the moment Bitcoin, Ethereum. If you're doing anything in a B2B space, because you're doing back-end process improvements, doing purchase orders, etc., most people on the public internet probably don't need to know or care about your purchasing of widgets, so you can do that in a private consortium between yourself and the other companies. In that case, you'd be doing a private consortium with Ethereum or Hyperledger, etc. Once you know if you're running in a public or a private blockchain, Then you can figure out the consensus algorithm. Is it going to be mining, like we saw? That's only really useful for public blockchains where we don't trust anyone. If we're in a private consortium, we kind of trust people in it, so we can use different types of consensus algorithms, which means you can do block times faster, get more transactions per second out. So we can use proof of stake, proof of identity, proof of authority, many, many, many different consensus algorithms. If you get to that point, you should probably bring me in. There's a lot of stuff to consider there. A final thing is to worry about, are you going to be working on blockchain 1.0 or 2.0 tech? So let's explore that. What does blockchain 1.0 give us? What does 2.0 give us? So 1.0 blockchains, these are the original ones that pioneered this. And all of these are single use case fixed function things where all the functionality is just built in, you can't change it. And this is Bitcoin, Dash, Zcash, Dogecoin, etc. Now, these are all good, but they all have single functions. And if we think where these ones fit in a typical 3-tier architecture, would have a user interface, business logic, and then data being stored somewhere. And blockchain 1.0 stuff is only really focusing on this data store area. So for example, who owns which Bitcoin? If we want to go and interact with the Bitcoin network, we need to have some business logic somewhere going executing on it, which means we have to trust whoever is running this business logic on our behalf. But now that because we have a trusted data store, at any point we can look at the data store and look up who has what Bitcoin. And so because we can use that to see the source of truth, it unlocks 3 main different use cases. Now, the first one being ownership. Now, the ownership can be over digital assets or physical assets. Digital assets can be things like, again, money, Bitcoin, Ethereum, but it could be for other digital items. Could be for Magic the Gathering cards or Yu-Gi-Oh! So when you're in the schoolyard, instead of having to physically have the cards, you can go and pull out your phone and prove that you own the Blue Eyes White Dragon. We can do it with World of Warcraft items. So I go and find a legendary. Hey, I can go sell it on a secondary market and go and do it on a decentralized exchange. Pokemon, if I'm going and doing a battle, just before the battle, we can go and verify that I do have that level 100 Pikachu. We can do all of that on here. Oh, and Counter-Strike skins and Team Fortress 2 hats. These things are going crazy. So these are just in-game skins you can unlock for your gun, which puts like flames and stuff on them. You get them from random unlocks. And so people are trading these for literally $10,000 just for a single, make your gun look pretty. And so there's heaps of fraud going on with this where people go and buy these skins online. People take the money, not send a skin. And so people are screaming out for some type of blockchain-based system to show who owns these items and they can trade it more securely. But they can do it with any digital asset, domain names, media. So with paintings and physical art, you can have one, and those things go for lots when you have an original by Van Gogh or something like that. But there's no equivalent in the digital space. So what some digital artists are doing now is they'll go take it, put a watermark over it, sell it, put it on the blockchain who the owner of this piece of digital art is to create some digital scarcity about who is the owner of this item. And they're doing this for when people are commissioning them to do things. So people can still go and on-sell who is the owner of this piece of digital artwork. And we could go and do it with physical assets. So who's the owner of this car? So the car could be smart to only let you and members of your family into the car. You can go and get insurance for your car because you can prove you own this car. You can do it with apartments, letting people in, things like that. So the first one was around ownership. Second one is around attestation, going and proving that something happened at a point in time. So it could be I go and sign a home loan. We go and take that home loan, run it through that cryptographic hash again, put it up onto the blockchain. So later on, if the bank and I are having a disagreement because the bank has gone, changed the paper contract to change it from 5% to 8% interest, I can pull mine out and go, no, like it was 5%. We'll go to the courts and would have lots of arguments. But if we can go and prove what the hash was of the original, we can go and prove that mine with the 5% was the real value. So this is being able to prove that stuff happened at a point in time. We can do the same thing with IoT data. So if we're in a factory or somewhere that needs lots of safety, we could go and every 10 minutes worth of IoT data, go build up a massive Merkle tree so we can have one value for that 10 minutes worth of data, keep putting it onto the blockchain, so later when the auditors come in and we're giving them all of the IoT data, because we're trying to prove that we did do the scheduled maintenance on this, we can go and prove that all of the IoT data is true and correct, because we've just got a couple of little Merkle tree hashes, so they can go and check that all the data we gave them is true. So attestation is a very important one. And this is where most of the customers I'm working with are worrying about this type of scenarios at the moment. And provenance is being able to go and track the origins of where items came from and where they've gone. So if we're going and building up a smartphone, we could go and check where all of the minerals were dug out of the ground, give each of those truckloads a hash value, all those come into the factory, get turned into metal, the bars of metal get tracked on the blockchain, go through until they make the circuit board, the CPU and the RAM. Each of those components have a unique serial number with their own hashes. So if again thinking about the Merkle trees, we could go and say that this smartphone, its value is made up of a massive hash of all of its individual components. So I can check if this phone is being modified. I can go and check all the serial numbers on the RAM and CPU, make sure no one's modified it. Same thing with things like vitamins, sending them to China. A lot of them want to make sure these are real authentic Australian vitamins that are going there. They can check the provenance of where it came from. Same with classic cars. They could go open up the classic car, check all the components, make sure it hasn't been updated or any parts replaced, because they can go and check the hash of the entire car and all of the are all the parts real originals. Okay, so that was blockchain 1. You can do some pretty cool stuff with blockchain 1, but it kicks it up into another gear when we start talking about blockchain 2. Now, blockchain 2 is blockchain 1 technology came out 8 years ago. No one paid it much attention until the blockchain 2 technologies came out around 2 years ago. And now this is why you're hearing lots of buzz about it when enterprises are starting to adopt it. It's because we go and raise it up, so it's not just a data store layer thing anymore, it's also, we can put business logic in here. So we don't have to trust other people's business logic. We can put the business logic in here, we can verify the business logic. Because it's in the blockchain, we can go and see that the business logic hasn't been updated, so they can't just change the 5% interest to 8% interest. And we can put a lot more trust and security in here now. And this is why people are starting to pay attention at this point in time. And it's because of these things called smart contracts. This is what puts the programmability into these blockchains. A smart contract just looks like a bit of TypeScript code. It's got functions, it's got some variables, it's got Boolean logic. We can do them in a Turing-complete way to do anything. Voting applications, like we saw in my very first use case, the two parties vote to unlock the funds to the seller. Now, a smart contract, you can think of it like a class. It doesn't do anything until you actually pay the cost to go and instantiate an instance of that class into a memory address. And so you'd have a deployed class as an object with a RAM memory address. Same thing here with a smart contract. When you go and deploy a smart contract, you pay the cost to deploy it into the blockchain, and now your deployed smart contract will have an address on the blockchain. So we can go and call into it, call the functions on this instance. It's got its static variables that stay there forever. And so with these static variables, you can go and see who has the Pikachu, who has voted to unlock the Pikachu to the next level, etc. Now, because blockchain 2 is Turing complete, anything that you could do with blockchain 1, each one of those different blockchain technologies were single fixed function use cases, just like calculators or pages. But when we got the new smartphones, these weren't single function anymore. You could load up multiple apps that could go and replace multiple old things with just one device now. So it's the same thing here with blockchain 2. So with Ethereum, what we're seeing now is what before would have been a brand new blockchain to do one function, that's now just becoming a single smart contract on the Ethereum network, which is why we're seeing all of these new tokens and coins appearing on here, because you don't have to run all new hardware. You just utilize the hardware and the running support on Ethereum to just host your new token. And these are the three main blockchain 2.0 technologies at the moment. What I've been seeing with all the customers that we've been talking to, It's about 90% of customers are using Ethereum. It's only banks using Corda because that's what it's built for banks. And Hyperledger is just used by a couple of people, a couple of companies. And from what we've heard, companies who've gone to try Hyperledger have gone, shit, and then gone on and jumped back over to Ethereum. Just because all of the developer mindshare and all of the things that are happening in the open source community and all of the tools and frameworks are mostly happening with Ethereum. Microsoft, we're supporting all of them, and you'll see later that we've got support for all of them. But if you want a heads up of what I'm seeing in the community, it's all Ethereum at the moment. Now, Blockchain 1 unlocked a couple of things. Blockchain 2 unlocks the programmability in that, but this is probably the most important thing for me, the contract-oriented architecture. So if you cast your minds back about a decade ago, when we were getting web services out, people were talking a lot about service-oriented architecture. And the dream and the promise of it was going to be that all these businesses were going to expose their business functionality as some web services. So you'd have 1-800-Flowers and hotels, etc., and be able to call into multiple of them and create brand new businesses and value by creating one application that would go and call into multiple web services. And it never happened, because what we discovered with service-oriented architecture was that everyone would create their web services differently. So it never happened. But then REST came out. Everyone went, okay, it's easier this time. It still kind of hasn't happened. We're seeing it happen a bit more now that we've got things like Swagger and that, but people still have different REST implementations. We have different exceptions coming out, etc. But now, if we've got a blockchain, we can have all that business functionality exposed as smart contract entrances into these companies now. So if I want to order an Uber, I could call the Uber smart contract, send me an Uber, book me a restaurant booking, etc. So I could go and create a new DApp, a decentralized application called a package state. So you go and pay for me once, and my smart contract could go and orchestrate for you and your significant other to go pick you up on the Uber, book a restaurant, and have a hotel room for you. So you can go and hook into all this orchestration much, much easier, because it's all just different contract addresses within the same blockchain. Your smart contract can hook into all of them. And so this networking effect is one that gets missed out a lot. Okay, so we've covered off all the basic technology, what a blockchain is, how it works, what's blockchain 1, what's blockchain 2, what have we got on offer on Azure Blockchain as a Service. So although my talk is, hey, let's cut out the corporations, I'm going to use, my corporation's paying for me to be here. So up on Azure, we've got Azure Blockchain as a Service. And as I said, we support all of the major blockchains, Ethereum, Hyperledger, Block App Strato, Parity, etc., and a bunch of developer tools. The idea here being that if you're doing any blockchain development and you need to have a private testnet sandbox to go and develop against, you can go and use Azure to spin up that private testnet for yourself and do it. Or in a scenario where you're doing a private consortium with yourself and a few other partners, like the article we released a couple months ago about how we helped WebJet with them and some of their partners. So we use this type of templates here to build up those private consortiums. So how it looks is you jump onto Azure, we've got a whole section for blockchain, click Ethereum or Hyperledger, etc. Click create, say which subscription you want it on, how many mining nodes, how many transaction nodes, how many different companies are going to be in this consortium so they can all self-host some of their own components. Click create, boom. Spins up all of the things behind firewalls, all the networking rules. You get pretty dashboards so you can see all of your mining nodes going on, what your average block time is, etc. So you get all of that. And because we're Microsoft and we're all about developer tools to help you guys build this stuff really easily, we've put support into Visual Studio Code. So you're getting syntax highlighting and things like that. And I'm using Ubuntu Bash and Windows 10 to go and do all of the smart contract unit testing, because these things are using real money. You need to do more unit testing than you usually would to make sure that you don't just lose millions of dollars. There was last year one bug. So it was literally just 2 lines that were flipped around. And because of that, $25 million worth of value was just lost, because some people were able to pull all of the money out because these 2 lines were switched. So you need to test more than you would. And I can go and deploy out my smart contracts out to the Azure network, get contract addresses, etc. Now, I've written an article about how I helped a company up in Brisbane rub a little bit of Devops on their blockchain, and we were able to go and use Visual Studio Team Services to go and do those smart contract compilation, unit testing, deployment, etc. It's online if you want to read it. And our massive blockchain as a service strategy is to help you build blockchain-based solutions. So what I just showed then was just this bottom bit, building up the basic infrastructure to go and host your blockchain network. But then we've got middleware and frameworks to help you build enterprise-level smart contracts. And just a couple of days ago, we just released this announcement around an open source framework called Coco that we're releasing, Consortium Contracts, I think it stands for, to help you write those enterprise-grade smart contracts on top of different networks. Now, the great thing about this is you can write it on this, and under the covers, you can use Ethereum or Hyperledger, etc. And so you can focus on this and just swap out the blockchains underneath it. And so this was all announced by our CTO at Microsoft of Azure, Mark Razinovich. So when we have the Microsoft CTO talking about blockchain, you know it's kind of a big deal. Okay. I was trying not to talk too much about what's up in Azure because I want to talk more about how you guys can use this stuff. So events in Australia. I've been to a bunch of different events here. We've got generic blockchain events, we've got crypto trading events, etc. What I've seen is a lot of them are just a lot of talk, or a lot of people just wanting to speculate so they can make mad millions from Bitcoin trading, etc. So what I've seen is these are the ones which talk actually about doing things, and these are the ones that have the tutorials and examples and show you how to actually do it. So I'd recommend joining one of those in Melbourne, Sydney or Brisbane. I help organise something called the Blockchain Association of Australia. And so we're running events in Melbourne and Sydney soon where we're bringing in international speakers to come and talk about this stuff. And so yeah, that's blockchain.asn.au, so I recommend you have a look at that. Earlier this year, I ran a 3-day Hackfest down in Melbourne where we blockchain-based hacking for the regulatory requirements in the energy sectors and finance sectors. Sorry, it's a mouthful. But we had 100 people in the community come along. We ran for 3 days. We had 14 teams that were a part of it and presented. And leading up to it, I ran multiple training events on how to get started with the blockchain and blockchain-based development. And I'm running another one later this year called the Smart Cities Blockchain Hackathon. So it's down in Melbourne, unfortunately, but I'm doing the same thing again, doing multiple training events leading up to it. Now, if you're not down in Melbourne, next week or the week after, I've got a bunch of video tutorials I'm releasing on how to go and get started with this using Ethereum, Truffle, Visual Studio Code. That'll be available online, so follow me on Twitter if you want those. Now, to summarize before I get into the use cases, the key takeaways I want you to take away, if you're going to take one photo, take it of this one so you can take it away. The main use cases are to use it as a trusted data source for the Attestation, for the Provenance, etc. The whole point of this is to try to remove those intermediaries that were there, those trusted third parties. And those trusted third parties were just there because we couldn't trust each other. We trust the blockchain and cut out those costs. We're doing it to attest that something happened. And most importantly, these networking effects that are going to happen once multiple businesses start building and releasing their smart contracts, being able to orchestrate calling to multiple smart contracts to build up new value between different companies. Another recommendation, just jump straight to blockchain 2, because there's nothing you can do with the 1.0 technology you can't do with the 2.0. And based on what we're seeing, go with Ethereum, because that's where all the developer mindshare is at the moment and all the open source tools. Now, some misconceptions to clear up. I hear these ones all the time. There's usually people who've heard of blockchain, they hear what it should be, so that's what's locked in their head. And as soon as they hear anything different, they start arguing with you because it's what they truly believe. Now, I keep hearing a lot that there should only be one blockchain. Any other blockchain that isn't the original public Bitcoin network is bad and evil because it means that the Bitcoin network isn't worth as much, so they're not earning as much money. No, there's going to be multiple blockchains. There's going to be tens of thousands of them. Most of them we won't hear or see anything about because they're going to be private blockchains between a couple of companies that we don't care about. There'll be a bunch of different public blockchains because they're going to be focused on different core value. The other one is must be public. I've just explained why you might want some business ones. Blockchain must be transparent. That doesn't have to be so. Now, you've got your bank account at the moment, and not everyone can read every single thing that you're buying on your bank account. So if we're all moving from bank accounts to cryptocurrencies, we don't want everyone to still be able to see everything we do. Especially if you're a business, you don't want your competitors to be able to see who all of your suppliers are easily. So there are things now called ZK snarks. So ZK snarks, zero knowledge proofs, that we can use now so we can put blockchain transactions in and no one can see what it was. It has no information about who it was from, how much was sent, who it was to, because instead of putting that plain text there, we put a cryptographic proof in there that something happened and no one can pull out what it was. So it can be completely anonymous. People can use it. And so the biggest one at the moment is Zcash. Zcash is one that does that. And those zero knowledge extensions are going to be pulled into Ethereum in a couple of months to be able to do private transactions in the Ethereum network. Again, so if you're doing business transactions, that would be very useful. And another one is that all blockchains must be secured with proof of work mining. No, it's only useful for public chains. And those public chains are the ones which people buy to earn lots of money. And so it's all of the Bitcoin miners that set up their big Bitcoin mining farms, mostly in China and other places with cheap electricity. So they have a vested interest in making it only mining because they keep earning their tens of hundreds of thousands of dollars a day from their mining. But if you're doing anything on a private consortium, you don't use proof of work mining at all. How am I going for time? Okay, 30 minutes left. Perfect. Now, what I want to spend the rest of my time on, now that you hopefully have some kind of idea of how a blockchain works under the covers, hopefully. I'm seeing lots of blank looks, I'm sorry. I want to spend the rest of the time talking about use cases. Because if you guys don't see a reason why you want to use this, you're never going to go to learn about it. So I just want to talk about ways we could. So let's start off with a car. Oh, wait, how many people here saw my Ignite talk? Cool. So let's start off with a car. Now, let's say this is one of those new Teslas that are coming out. So we've got a factory. And we saw how we can go and track the provenance of the origins of where a car came from. So we can go track the provenance where each of those parts came from. We can check this is an original authentic car if collectors care about vintage electric cars. But Microsoft, we've got a project that we're building at the moment called Project Manifest, where we're allowing companies to be able to track this stuff. We track the IoT data automatically coming through. They go through different logistics pipelines to pump it all in, secure it with a blockchain. And so there's some blog posts on this if you're interested in one way to do this. So we've got a Tesla. That's great. But let's say someone wants to buy it. But that's too easy. Let's say we've got a group of people that want to buy it. It's a retirement home. And so they've got mobility problems. They want to go and get out and about, but they don't want to keep hiring a driver. So they just want to grab an autonomous Tesla to come pick them up. Now, the problem with that is traditionally they'd have to pull all of their money together and one person would have to collect it all, Jeff, and Jeff would collect it, but Jeff would just run off to the Caribbean with all of their retired people's money. So, and that's because we have to put our trust in one person. So let's remove the trust from that one person and trust the blockchain instead. And so if they're trying to get this money together, they would do it through a neighborhood crowd fund for that retirement home. Now, they could use something like Kickstarter, but we're only using Kickstarter because we need a trusted third party to do it. And Kickstarter take a big chunk of money for being that intermediary. So let's use decentralized crowdfunding. Now, there's Wayfund is one of them, and it's the same thing. It's just a smart contract where people can go put the money in to do the crowdfunding. So we cut out those middlemen, we're reducing our costs. Okay, they bought the Tesla, but now arguments are coming up because some people want to pay for the scheduled maintenance, some people don't want to do it. They're having arguments around time sharing, so they need some sort of governance model around this. And there's a DApp for that. So Boardroom. So Boardroom allows people to go and set up decentralized organizations where there's no single CEO or owner of a company or a single decision maker. You can put these decisions inside of a smart contracts now. They all vote on what the outcome should be for these decisions. Should we go to get the scheduled maintenance done? Enough of them vote yes. It unlocks some of the funds from their shared blockchain wallet to go send the funds to the maintenance crew. Okay, now they're happy. All these arguments have stopped, the time sharing is going well. But what they're seeing now is that a lot of the time the Tesla's sitting there doing nothing. And if you've read Elon Musk's blog posts, he's talked about, well, if your autonomous Tesla's sitting there doing nothing, why can't it go off and make money for you? So you can make it go work for Uber, but again, Uber's taking a cut for being a trusted third party. So we could go and use a ride-sharing DApp to cut them out. And cool things that happen once we replace it with a smart contract here, every time the car goes out, picks up a passenger and the passenger pays, they'll pay into the ride-sharing DApp. Sure, they may take a small car, but it'll be much smaller than Uber, maybe 0.5% or something. The rest of the funds will go up into here, and then based on the shares of how much they bought, the funds will automatically go and be split up automatically every single time a ride gets paid. Automatically. And they can check that Jeff isn't just keeping all the money and not paying out correctly because it's all there on the blockchain being orchestrated by smart contracts paying out based on their shares. Now, we've got randoms getting into our car. So we're going to have to pay for a higher insurance premium. But what if we could just buy insurance as we're picking up a new passenger? So we just get a higher level of insurance just for that single ride. So again, this could just orchestrate buying it from the insurance DApp each time a new passenger is getting into the car. And this Tesla, whilst driving around, it could have its own crypto wallet with Bitcoin in it, so it can go off to go and charge itself at charging station by itself. So this car can be really autonomous. Now, there are dApps to do this. There's Swarm City for decentralized peer-to-peer ride sharing. There are dApps to do insurance. All this stuff is being created at the moment. Okay, we're riding in the car and we want some music. So we go and open up Spotify and listen to the music. Now, what happens is, although we listen to it on Spotify or we buy their tune from iTunes, the artist, the creator of value, they're only going to get a tiny, tiny cut. We're talking, 10% if they're lucky, and all the value is being sucked out by the record publishers, the record labels, the promoters, etc. So the value creators aren't getting rewarded for what they're doing. Let's change that. Let's cut out all those corporations and replace them with a decentralized application. So whenever we go and buy it now, the artists can be in control of how much they sell each of their pieces of music for. They can decide who gets paid out what the percentage shares are. And the cool thing is, once this is a decentralized app and you can just get music licenses, again, this networking effect of shared contracts being able to call into each other hooks in. So now, if we're doing something like live streaming music, or each time it's played an advertisement, it could just go and just get a micro rights from that transaction to go and play this piece of music just for this once. And so Ujo Music has this. We can see we've got this song, you can buy it for 60 cents. You can see each of the people who were involved in this, the brass ensemble, all the people, etc. You can see how much it is for each each time to stream the song once. It's a 1/6 of a cent. You can see all of the things you get with it. But importantly, you can see that the main artist who created it, you can see what the shares are going to, the percentage split is going to be for each time a song's sold. So she's assigned 90% of it to herself, and she's come to an agreement with the brass ensemble and the down here the marketing people. Each time the song gets sold, each one, they get a 1% cut. So they can go and do it. So maybe she gets a better mixing engineer on who, because they're more high profile, haggles with her to get a higher percentage, a 2% cut or something like that. But the point is, the main value creator now is in control of this. And we can see on the blockchain that the piece of music is being purchased, and so the people who are getting the percentage cut can go and verify that they're getting paid out correctly, which they are because it's all being done by a smart contract. Okay, continuing on. This is where we start getting more futuristic. So we've got people who are not part of any of this at the moment, not part of the global economy because they can't afford to be. Around the world, we've got, conservative estimates are 2.5 billion people around the world at the moment who can't be a part of the global economy because they can't afford a bank account, because how much the monthly fees are for a bank account is more than they get paid in a day. So they just can't afford to have a bank account, which means we go right back to that very first scenario I talked about, where they have to physically rock up, have the money on them, pay for it to exchange the goods and go away, which means they can't buy anything in the next village. They definitely can't buy anything overseas because they're kept out of that global economy. So we see that the third world does a great job of just leapfrogging technologies. We saw it with telephones. They leaped over landlines, went straight to mobile phones. We're probably going to see the same thing here. Getting into the global economy, they'll just leapfrog over traditional banks and go straight up into cryptocurrencies, which means, boom, we're cutting out the big banks, conglomerations, corporations, etc. And once they're in the global network with their own blockchain wallets, it means now they can be part of the global economy. They can go create music, which they are now in control of. They're getting the value. So we can go and unlock all of the creative potential of all these people around the world just by giving them access to blockchain wallets. They can go create other decentralized apps and they can get the money, etc. Now, this was all talking about consumer to consumer and business to consumer. Back over here, we can talk about business to business stuff. So we've got the Tesla factory with the suppliers and logistics networks and things like that. This goes back to a private blockchain and a private consortium because no one else needs to know about this. And for competitive advantage, they don't want their competitors to know who their suppliers are, how many purchase orders they're doing, when they're getting the next shipment of silicon, etc. There may be another one for government, so for around regulation, for the emissions testings on cars. So that would stop things like the scandal with BMW, putting in fraudulent emissions testing. They will go certified on the blockchain. So if later if they say, oh, it was a mistake, we can say, no, you said it was that. So we can go track all of this. So the point of this is just to show that all of this can be massive network effects from smart contracts, multiple different blockchains here. It's not just one blockchain to rule them all. They all have different use cases. Now, across all of this, we're going to need identity. Now, with Microsoft, we're doing things around identity that we've talked about. So we can use things like Azure Active Directory to have blockchain accounts. So then we can track identity in this type of space. But in the consumer space, if we're hooking into this, how do we do it? There's multiple different ways, but the biggest one at the moment is called UPort. And so you can have multiple digital identities in here. And you can go and interact with multiple different dApps. And I'll come back to why having digital identities is important later. Sorry, you want to? Okay, so that's that big scenario. And so all of that was what you can do now. And so I want to talk about, with the last 10 minutes I've got, a lot of what we can kind of do in the very near-term future, as in 6 months, a year. It's not that far away, any of this stuff. And again, yeah, this is just in Japan. So Alex is taking some awesome photos around at the moment. So let's start off with stock exchanges. So stock exchanges are all done in a centralized way, etc. Now, there are good reasons why they do that, for regulatory, etc. But general users who just want to go and just exchange to try and earn a bit of money with day trading by themselves, they don't bother with it because it's way too much overhead. But now that we're seeing this stuff happen in cryptocurrencies, we're seeing a lot of just random people who've never been into trading before starting to get into it. Now, we do have centralized exchanges like Mt. Gox and B2C markets and things like that. But we can see what happens when we've got a centralized entity that we need to trust. So Mt. Gox a couple of years ago, that was one cryptocurrency exchange where you could go and buy and sell Bitcoin. You could exchange Bitcoin for Ethereum and things like that. And so you would send your Bitcoin to them, they would keep it in a wallet, and then they'll send you some back. And you're trusting that they will send it back to you. But what happened was lots of people kept their Bitcoins in there because they would go and do day trading, etc., things like that, and they got hacked. And I forget how many tens of millions of dollars worth of Bitcoin were just stolen because one entity was in control of all of it. And so, and they also take really big fees for the privilege of being able to buy and sell Bitcoin and trade through them. So even these really new businesses which are based around blockchain, they are being replaced because we don't need them if we can do it in a decentralized way. So now there are actually smart contracts where you can go and do decentralized peer-to-peer trading now. One person puts up, I will trade X number of Bitcoin for X number of Ethereum. Other people put what their buy sell rates are. The smart contract to do it all. Boom. Cutting out those centralized people. We're cutting out those big fees, and we're doing it much, much faster and securely because I don't have to trust that they'll send it to me. It will happen automatically all through those smart contracts. Now, those are stock exchanges, which moves us on to ICOs. So you're probably hearing a lot about ICOs at the moment because it again goes back to general people not using the stock exchange because it's too much overhead. Same thing with people wanting to invest into new businesses. So venture capitalists just have a monopoly on being able to give out big amounts of money to companies who want to go and raise money. But general people just want to invest a little bit of money here and there. And so what we're seeing now is lots of new startups are just completely bypassing venture capitalists and angel investors and just doing it via a smart contract instead. These initial coin offerings. They deploy a smart contract that says for every $100 worth of Bitcoin you put in, you get X number of shares of this company or X number of tokens to use the services that we're about to launch. And so we've seen over the last couple of months, there were 5 different ICOs where in 30 seconds, they raised $25 million in 30 seconds. And so those blocks were just saturated and they sold out in 30 seconds. Because they put caps on it of $25 million just so one wallet wouldn't have too much money so they'd be a target for hacking. And this is happening now. And so you're just hearing multiple tens of millions of dollars being raised in just minutes at the moment. Again, because people just want to get cut out these corporations and do it themselves because it's just so much easier. Identity and reputation. I talked before around Uport, being able to have a digital identity. Now, the great thing about this is this is one of the reasons why I've got such a draw towards blockchain. Because I'm sick of companies like Facebook taking all my personal information. They've got it in their data silo. I have no say over what they do with it. I think it's ... And so blockchain gives us a chance to be able to take the power back. Once we start going to these decentralized applications with multiple digital identities, we can go on the blockchain and say who has access to our name, who has access to our identity. It also means that we can prove things without actually showing them our real identity. So it may be when we go into a club, they need to know that we're over 18, and they take a photocopy of my ID when I go into a club. I hate that. They know who I am. They just need to know that I'm over 18. So with these digital identities, you could go get a cryptographic hash proof from the government saying, yes, I am over 18. It's attached to my identity. They don't have my name or my date of birth. It's just a cryptographic proof that I'm over 18. So I can go and show that to them and they can let me in. Same thing with if you need to show that you're an Australian citizen. They don't have to see my real passport with all my details on it. They just have a cryptographic proof that I am an Australian citizen. So a lot of these things where people need the real data, they don't need the data anymore. They just need the proof that I am. So we can be a lot more private about this and take back control back to ourselves. It also means that we can split up our digital identity a lot easier because I do this a lot myself. I've got my professional persona, which is me up on Twitter. But I don't want people to know what I do on Reddit, for example. Please don't look at what I upvote on Reddit. And I've got my identities on when I game, things like that. Because I don't want my, when I'm on LinkedIn, people to see that I'm messing around in League of Legends. It's just, I don't want people to know that. So you can do this with multiple digital identities. You can have a trading persona and one that you do when you're doing your digital asset creation when you're being a creative, and the one we're doing over here. Again, taking the privacy back into you. And you have a single wallet with multiple identities that you can use. Also means that when we have the digital identities, we can do great things around reputation. So at the moment, you've got a problem when you use Uber, you have one reputation score. On eBay, you have one reputation score. On Amazon, you have one reputation score. And all in totally different data silos. Your reputation doesn't carry across with you. If you have digital identity and these all going through smart contracts, now against that digital identity, a reputation score can be attached to it. So although I'm a great seller on eBay, on Etsy, I have no score. But my reputation could now be carried around with me. So that, again, is taking it back from the corporations having control of our data and reputation, and we're pulling it back towards us. Programmable tickets is an interesting one. So we've got a problem with event ticketing. Tickets get sold, like with NDC, and there's always a secondary market for these things. So it could be a Lady Gaga concert, etc. You have ticket scalpers who will buy them all up and sell them on the secondary market. And so lots of arguments back and forth about this. But one of the main ones that the event organisers hate is that they're sold on secondary market and they don't get a take of it. What we can do is instead of issuing physical tickets or a digital ticket, which is just a PDF with your barcode on it, we can actually go and issue each person on the blockchain their ticket. Now, if we do it as a smart contract, it means we can now make these smart. We can go and put programmability into these event tickets. So we can have a function on this ticket, which is a transfer ownership. So I brought my ticket, it's assigned to me, so when I go and scan into the event, yeah, I'm let in. But they won't let me go sell it off to Darren because he wants to go to Britney Spears instead of me. And so, but I'm not allowed to transfer the ticket. The function on there, transfer ownership, I can do that. So I've got control. I can do it on a peer-to-peer decentralized network on the secondary market. But what the event organizers could do is inside of that function, the transfer ownership function, they can hard code a thing that says, yeah, okay, we will let you on-sell this ticket to other people, but you have to pay a penalty fee each time you do it. And so they can put these smarts into these event tickets saying, yes, do that, but you have to pay us for a small cut to change the name, who it's on, etc. Or you can get a refund if you call the refund function on it. So this is a great thing, being able to take what were before just previously dumb physical tickets or tokens and then put some smarts onto them. Talking of physical tokens, on the flight back to Australia, I watched John Wick. It was very, very cool. Again, very lots of neon photo colours in there. Now, one thing that happens in there is they had their whole economy. The Assassin's Guild, to go and get anything done, they had these gold coins that they go and trade. So they'll go and do favours for people, or they'll go and do a hit job, and they'll go and get paid, they'll pay each other with these gold coins. There's a hotel in there called the Continental. You can go and stay at the Continental if you have these Assassin Guild coins to pay. You can use it to go and trade it for body armour, suit up with guns, etc. Now, these are physical tokens. They have to physically go and do it, and which means that they're carrying a whole bunch of really valuable tokens on themselves. They could get mugged and they're stolen. We could change these to just a single smart contract up. So now all these Assassin Guild tokens are now up on a network. They can go and trade them. And so Cyberpunk Future, we've now got ninja assassins doing stuff with cryptocurrencies. So I've got about 3 minutes left, so that's good. I've only got 2 main slides left. This is going super futuristic now. So device autonomy. So we talk about autonomous vehicles, autonomous cars, autonomous planes. What about hackers? Hackers who are going to go modify the firmware so the car's going to go and drive off a cliff. What if the car could start up, it checks the cryptographic hash of its own firmware, it goes and checks the blockchain to see what all the other cars have on their blockchain ledger about what the hash of the firmware should be. They can check if their firmware hasn't been modified. So we can go and do IoT security really great with this decentralized network. We don't have to have a centralized authority about this. All the IT devices can talk amongst themselves about what the source of truth is. And we can get super futuristic if we start thinking about Darwinian genetic evolution of artificial intelligences. So if we go and got a whole bunch of artificial intelligence, we're talking 5 years' time or something, where they can go and we want them to earn as much money as they can. We give them a little bit of Bitcoin each, say, okay, you have to pay for your own server hosting on Azure. Here's your Bitcoin wallet. And so they're all there with their fitness functions trying to go and earn money. The ones which are bad at it would just die because they can't pay for their own hosting. The ones that are good at it will earn enough money to keep paying for their hosting, get more server hardware. They could spawn off new children with different subsets of AI, go give it fragments of its Bitcoin wallet so it can keep on doing, get some Darwinian evolution from AI. At this point, we get to like the end of the Neuromancer book where the AI escapes and does bad stuff. But again, cyberpunk. But this is the most cyberpunk example I could think of, and you can get these right now. So in all these cyberpunk books and movies, you always hear them having credit sticks. They can go up and trade credit sticks to get things done. Now, these are little USB things which have a little processor on it. It will go and generate a private public key in the processor so that they've never been leaked ever. You plug them in, you can see what the public address is for this Bitcoin wallet. So you can go load it up with like half a Bitcoin. So now I've got a wallet, a credit stick with half a Bitcoin on it. I can go trade it for what I need out on the street, and we can go and trade this credit stick with half Bitcoin on it. The only way to get the money out is this little hole here. You have to get a pin, punch it out, it pops off this resistor, which goes and modifies the processor. At that point, it unlocks the private key, so you have to bust open the credit stick to get the private key so you can go and spend these credit sticks. That's awesome. That's awesome. So we think about in the future, all the corporations hate me now because I've been telling you guys how we can cut them out. So I have to go out onto the streets to go and buy some credit sticks. So I've gone down to, this is our Kabukicho. So I've gone down there, gotten it. I've used one of my other digital personas to go call a decentralized Uber to get me out of inner Tokyo. I go down the side street, find the old man down there. I pass him the credit sticks to let me into the club, to give me some sanctuary. Unfortunately, the corporations use those John Wick assassin's tokens and they've dumped me in the water. So with that, I've been David Burela. Add me on Twitter if you want those tutorials. Thank you.